Have you ever wondered why one of the world's most powerful air forces is spending billions of dollars on an aircraft that first flew before most modern nations even built their jet fleets? In an era dominated by stealth fighters, hypersonic missiles, and artificial intelligence, logic would suggest that a bomber designed in the early 1950s should already belong in a museum. Yet somewhere above the horizon, a Boeing B-52 Stratofortress is almost certainly flying another mission. Not as a relic kept alive by nostalgia, but as an active pillar of American military strategy. The real question is no longer why the B-52 survived. The question is why the United States believes its greatest years may still lie ahead. For decades, military analysts predicted the aircraft's retirement. Every new generation of bombers seemed destined to replace it, and every leap in aviation technology appeared to push the old giant closer to the scrapyard. Faster aircraft entered service, stealth technology reshaped aerial warfare, and digital battle networks transformed the way wars were planned. By all conventional wisdom, the B-52 should have quietly faded into history alongside many legendary Cold War machines. Instead, it remained on flight schedules, continued receiving upgrades, and kept returning whenever another international crisis demanded long-range firepower. The story of the B-52 Stratofortress is not simply about an airplane with extraordinary longevity. It is about how military power evolves without always abandoning the past. Sometimes the strongest weapon is not the newest design rolling off an assembly line, but an existing platform capable of adapting faster than its rivals. That philosophy has shaped American air power for generations, and no aircraft demonstrates it more clearly than this enormous 8-engine bomber. Every decade has tested its relevance, yet every decade has also revealed another reason to keep it flying. Today, the United States Air Force is investing more than $12 billion into transforming the B-52H fleet into the next-generation B-52J. That decision surprised many observers around the world. Why pour enormous resources into an aircraft older than most of the pilots who now operate it? Why not build an entirely new bomber instead? Hidden behind those questions is a strategic calculation stretching far beyond a single aircraft. It reflects how the United States intends to project power across the globe for decades to come. To understand that decision, we have to travel back to a world still recovering from the devastation of the Second World War. The victory celebrations had barely ended when another confrontation quietly began taking shape. The alliance that defeated Nazi Germany quickly fractured as the United States and the Soviet Union entered a rivalry unlike anything history had seen before. Nuclear weapons changed every military calculation overnight, and geography suddenly mattered less than the ability to reach any target on Earth. Air power became more than a battlefield advantage. It became the foundation of national survival. American planners realized that future wars might begin without warning and unfold across continents rather than front lines. The United States needed an aircraft capable of carrying massive payloads over intercontinental distances while remaining ready for immediate deployment. The mission demanded exceptional endurance, enormous carrying capacity, and reliability that could withstand years of constant readiness. Designing such an aircraft was a challenge that few companies could even attempt. Boeing accepted the task knowing that success would redefine strategic aviation. The path toward the B-52 was anything but straightforward. Engineers repeatedly revised the design as new technologies emerged and military requirements evolved almost monthly. Drawings were discarded, structural layouts were rebuilt, and propulsion concepts changed before a final configuration finally began to take shape. Inside engineering offices, countless debates unfolded over wing geometry, engine placement, structural strength, and aerodynamic efficiency. The aircraft that eventually appeared on the runway looked dramatically different from many of its earliest concepts, reflecting years of relentless experimentation rather than a single brilliant idea. When the YB-52 prototype finally lifted into the sky in April 1952, it represented more than another successful test flight. It marked the arrival of a bomber built for an entirely new kind of global conflict. Stretching over 185 feet in wingspan and powered by 8 turbojet engines, the aircraft promised unprecedented reach and carrying capacity. It could transport tens of thousands of pounds of conventional or nuclear weapons while covering distances that previously required multiple aircraft or overseas bases. For American military planners, this was not merely another bomber. It was an insurance policy for an uncertain nuclear age. As the B-52 entered operational service in 1955, its arrival immediately altered strategic thinking across the world. Soviet defense planners faced a difficult problem. Traditional interceptors struggled against an aircraft capable of flying high, traveling immense distances, and remaining operational under demanding conditions. Radar networks expanded, missile programs accelerated, and new interceptor aircraft entered development, all partly influenced by the challenge posed by America's growing fleet of Stratofortresses. Even when countermeasures improved, the B-52 continued evolving alongside them, creating an ongoing contest between offense and defense. What many people forget today is that the aircraft was never expected to enjoy such extraordinary longevity. Engineers believed newer technologies would inevitably replace it within a few decades. Aviation during the 1950s advanced at breathtaking speed, and every year seemed to introduce another revolutionary concept. Few imagined that an airplane design during the early years of the Cold War would still play a central military role well into the 21st century. History, however, has a habit of ignoring even the most confident predictions. Public perception eventually became trapped by appearances. The B-52 looked old, and to many observers, old automatically meant obsolete. New bombers appeared sleeker, stealthier, and more technologically impressive. Television broadcasts highlighted advanced fighters with futuristic cockpits, while the Stratofortress retained the unmistakable silhouette first seen generations earlier. It became easy to assume that the aircraft remained in service only because replacing it was too expensive. Reality turned out to be far more complicated. Beneath its familiar exterior, the B-52 changed continuously through decades of modernization. Navigation systems evolved from analog instruments to sophisticated digital avionics. Precision-guided weapons replaced many unguided bombs, dramatically expanding the bomber's effectiveness. Communication systems, electronic warfare equipment, targeting capabilities, and mission planning software advanced with each major upgrade, allowing the aircraft to perform missions that its original designers could never have imagined. The aircraft's greatest strength was never raw speed or stealth. Instead, it possessed an unusual combination of range, payload, flexibility, and adaptability that proved remarkably difficult to duplicate. Unlike specialized aircraft designed around a single mission, the B-52 repeatedly reinvented itself to match changing military doctrine. As new missiles entered service, it became an airborne launch platform. As precision warfare expanded, it evolved into a long-range strike asset capable of attacking targets without entering heavily defended airspace. Rather than resisting technological change, the bomber absorbed it. That adaptability gradually reshaped American strategic planning. Instead of viewing the B-52 as a temporary solution awaiting replacement, defense leaders increasingly recognized it as a durable foundation upon which new technologies could be layered. Every modernization extended not only the aircraft's lifespan, but also its strategic value. The bomber became less about its age and more about the possibilities created by its enormous airframe, proven reliability, and unmatched capacity. By the beginning of the 21st century, what once seemed like an aging survivor had quietly become one of the most cost-effective long-range strike platforms ever built. Still, one enormous challenge remained unresolved. Time eventually catches every machine, no matter how successful its design may be. The engines powering the B-52H dated back to another era. Maintenance requirements grew more demanding each year, and sustaining the fleet became increasingly difficult. Spare parts became harder to obtain. Technicians relied on extraordinary ingenuity to keep aircraft mission-ready, and questions about the bomber's future grew louder. Many believed this would finally become the obstacle the Stratofortress could not overcome. But behind closed doors inside the Pentagon, Boeing facilities, and the offices of defense contractors, another vision was already taking shape. Instead of preparing the B-52 for retirement, military planners were preparing it for its most ambitious transformation since the Cold War began. The aircraft that once symbolized nuclear deterrence was about to become something very different. What emerged from those discussions would eventually be known as the B-52J, a modernization program that would challenge almost every assumption the world held about aging military aircraft. The turning point in the B-52 story did not begin with a new engine or a cutting-edge radar. It began on battlefields that its designers had never anticipated. When the aircraft first entered service, its primary mission revolved around nuclear deterrence. It was built to stand ready for a conflict that everyone hoped would never happen. But history rarely follows military blueprints, and before long, the Stratofortress found itself flying toward a very different kind of war. By the mid-1960s, the conflict in Vietnam demanded capabilities that strategic planners had not originally envisioned for the bomber. Instead of preparing for intercontinental nuclear missions, crews were tasked with supporting conventional operations over Southeast Asia. Dense jungle, elusive enemy positions, and rapidly changing battlefield conditions created challenges unlike anything imagined during the aircraft's design phase. Many questioned whether such a massive strategic bomber could adapt to an unconventional war. The answer would be written over thousands of combat sorties. Operation Arclight marked the beginning of that transformation. As formations of B-52s departed for their first combat missions, the operation faced tragedy almost immediately when two bombers collided before reaching their targets, costing the lives of several crew members. It was a devastating reminder that even before encountering enemy defenses, military aviation carried enormous risks. Yet the remaining aircraft continued the mission, demonstrating a level of discipline that became characteristic of the bomber community. The operation succeeded despite the losses, establishing the B-52 as an integral part of American air operations. Over the years that followed, the Stratofortress became one of the most recognizable symbols of American air power in Vietnam. Mission after mission, crews flew exhausting sorties that demanded precision, endurance, and coordination across enormous distances. The aircraft delivered immense volumes of conventional ordnance in support of military objectives, reshaping battlefields on a scale few other platforms could achieve. While debates about strategy and effectiveness continue among historians, there was little disagreement about one fact. The B-52 had proven capable of adapting to missions far removed from its original nuclear role. The end of the Vietnam War did not signal the end of the bomber's usefulness. In many military organizations, an aircraft subjected to years of intensive combat would eventually be retired in favor of newer designs. The United States Air Force chose a different path. Instead of replacing the B-52 outright, engineers examined every lesson learned from combat and searched for ways to improve the aircraft. Each conflict became not the final chapter, but another opportunity to reshape its future. Throughout the 1970s and 1980s, modernization quietly accelerated. New navigation equipment reduced dependence on older analog systems, improving accuracy during long-range missions. Advances in electronic warfare enhanced survivability against increasingly sophisticated air defense networks. Communication upgrades connected bomber crews more effectively with command centers spread across multiple continents. These improvements were often less visible than a new aircraft rollout, but together they steadily transformed the Stratofortress into a far more capable platform than the one that had first entered service decades earlier. The collapse of the Cold War order introduced another test. Many assumed that the end of the Soviet Union would reduce the importance of strategic bombers altogether. Defense budgets tightened, military priorities shifted, and countless Cold War programs disappeared. Once again, observers predicted that the B-52's retirement was only a matter of time. Yet another regional crisis soon demonstrated why long-range bombers remained relevant. When Operation Desert Storm began in 1991, the nature of aerial warfare had changed dramatically. Precision-guided weapons were redefining combat, satellite navigation was becoming increasingly important, and coalition forces sought to minimize unnecessary destruction while maximizing operational effectiveness. The B-52 entered this environment carrying capabilities unimaginable during the Vietnam era. Rather than relying solely on traditional bombing methods, it now integrated advanced targeting systems with long-range cruise missiles capable of striking from well outside heavily defended areas. For the first time, heavy bombers launched AGM-86 air-launched cruise missiles in combat, demonstrating a completely different approach to strategic strike operations. Instead of penetrating dense enemy air defenses directly, the aircraft could remain hundreds of miles away while delivering precision attacks against key targets. This approach significantly reduced operational risk while expanding strategic flexibility. The mission illustrated an important truth that many critics had overlooked. The B-52 was no longer simply a bomber. It had become a mobile launch platform for increasingly sophisticated weapons. Military planners paid close attention to those results. Every successful mission reinforced confidence that the aircraft's enormous payload capacity could support not only gravity bombs, but also evolving generations of precision-guided munitions. As missile technology advanced, the bomber's relevance actually increased. Its spacious internal systems and external hardpoints allowed engineers to integrate new weapons without redesigning the entire aircraft. That adaptability became one of its greatest strategic advantages. Conflicts in the decades that followed further strengthened that reputation. During operations connected to Afghanistan and Iraq, the B-52 demonstrated remarkable versatility by supporting troops on the ground while remaining capable of strategic long-range strikes. Modern targeting technologies allowed crews to respond more rapidly to changing battlefield conditions than many observers expected from such an old aircraft. Instead of functioning solely as a Cold War relic, the Stratofortress became a flexible participant in 21st century military operations. What made these deployments particularly significant was not simply the aircraft's firepower. It was the confidence commanders placed in its ability to remain airborne for extended periods while carrying a wide variety of weapons. Long endurance allowed bomber crews to adapt as missions evolved, supporting multiple objectives during a single sortie. Few aircraft combine persistence, payload, and global reach as effectively. That combination repeatedly justified the Air Force's decision to keep investing in the platform. Meanwhile, something unusual was happening within the broader American bomber fleet. Aircraft once introduced as revolutionary successors gradually approached retirement themselves. The Convair B-58 Hustler had already disappeared from service years earlier. The Rockwell B-1 Lancer, once promoted as a cornerstone of future strategic aviation, began moving toward the final stages of its operational life. Even the Northrop Grumman B-2 Spirit, famous for its stealth capabilities, would eventually transition as the B-21 Raider entered service. The irony became impossible to ignore. The airplane everyone expected to disappear first had quietly outlasted every bomber originally intended to replace it. Generation after generation came and went, while the Stratofortress continued flying operational missions across the globe. This remarkable longevity was not an accident of bureaucracy or institutional resistance to change. It reflected a deeper understanding of what strategic aviation truly required. Unlike aircraft optimized around one revolutionary technology, the B-52 possessed extraordinary room for continuous evolution. Its massive airframe accommodated new electronics, upgraded sensors, additional communication equipment, and entirely new categories of weapons without fundamentally changing its structure. Engineers discovered that modern systems could be integrated into an aircraft originally designed with slide rules and drafting tables. Few military platforms have demonstrated such flexibility across so many decades. Economics also played a crucial role. Designing an entirely new strategic bomber demands enormous financial investment, years of testing, and extensive production infrastructure. Even after entering service, a new aircraft requires fresh maintenance procedures, logistics networks, training programs, and supply chains. The B-52 already possessed all of those advantages. Decades of operational experience meant technicians understood its strengths and limitations in exceptional detail, allowing modernization efforts to focus on capability rather than rebuilding an entire support ecosystem from scratch. As defense planners looked toward future competition with increasingly capable adversaries, they recognized that replacing the Stratofortress outright might actually reduce overall strategic flexibility. A bomber able to carry enormous payloads across intercontinental distances remained valuable regardless of whether the weapons aboard were conventional bombs, cruise missiles, anti-ship missiles, or entirely new systems still under development. The platform itself had become less important than the possibilities it enabled. That realization fundamentally changed the conversation surrounding the aircraft. Instead of asking how much longer the B-52 could survive, military leaders began asking how much more capable it could become. Advances in propulsion, digital avionics, radar technology, and long-range precision weapons suggested that the old bomber still possessed untapped potential. What had once been viewed as a limitation, its age, was increasingly overshadowed by its extraordinary adaptability. Inside Air Force planning offices, discussions gradually shifted from life extension to transformation. The goal was no longer to keep an aging fleet operational for a few additional years. The objective became creating a bomber capable of remaining relevant well into the middle of the 21st century. Achieving that vision would require replacing systems that had served faithfully for decades while preserving the airframe that made the aircraft unique. Those plans would eventually evolve into one of the largest modernization efforts ever attempted on a strategic bomber. Engineers prepared to replace engines that had powered the aircraft since the early 1960s. New digital architecture would support future software upgrades, advanced radar systems, and next-generation weapons still in development. The familiar silhouette would remain largely unchanged, but beneath its skin, the Stratofortress was preparing for a technological rebirth unlike anything in its remarkable history. The world would soon discover that the B-52 was not simply surviving the future. It was being redesigned to help define it. The transformation into the B-52J is often described as an upgrade, but that word barely captures what is actually taking place. From a distance, the aircraft will still carry the unmistakable profile that has dominated American strategic aviation for generations. Its long wings, distinctive landing gear, and familiar fuselage will remain instantly recognizable. Yet beneath that iconic exterior, engineers are replacing many of the systems that determine how the bomber flies, fights, and survives in a modern battle space. In many respects, the B-52J is becoming a new aircraft wrapped inside one of the most recognizable airframes ever built. The most urgent challenge centered on the aircraft's engines. For decades, the Pratt & Whitney TF-33 turbojets had powered the B-52H through countless exercises, deployments, and combat missions. They had performed faithfully, but time was becoming an unforgiving enemy. Manufacturing lines had long since disappeared, replacement components became increasingly difficult to obtain, and maintenance crews often relied on extraordinary creativity just to keep the fleet mission ready. Every additional year demanded more effort simply to sustain the same level of readiness. Inside maintenance hangars, the reality was far less glamorous than the aircraft's legendary reputation suggested. Technicians inspected aging hardware that had already exceeded expectations by decades. Every inspection required careful attention because the bomber's operational schedule allowed little room for extended downtime. Behind every successful mission stood countless hours of maintenance performed by specialists whose work rarely appeared in headlines. Their dedication kept one of America's oldest combat aircraft flying in an era dominated by far newer technology. Recognizing that the existing propulsion system could not support another generation of service, the United States Air Force launched the Commercial Engine Replacement Program. After evaluating available options, Rolls-Royce's F-130 turbofan was selected to power the future B-52J fleet. The decision represented far more than replacing worn-out machinery. It established the technological foundation upon which the bomber's next several decades of operational life would depend. Replacing all 8 engines across the fleet is one of the most ambitious elements of the modernization effort. The F-130 promises significantly improved fuel efficiency compared with the aging TF-33, allowing the aircraft to fly farther while consuming less fuel. That improvement has consequences reaching well beyond simple operating costs. Greater efficiency reduces dependence on aerial refueling, expands mission flexibility, and allows commanders to deploy bombers over even greater distances with fewer logistical demands. In an era where global reach remains essential, every additional mile matters. Reliability may prove even more important than efficiency. Modern engine technology dramatically reduces maintenance requirements compared with equipment designed during the early Cold War. Instead of constantly searching for obsolete components, maintenance personnel will operate systems supported by active production lines and modern manufacturing techniques. This shift allows crews to focus less on keeping old engines alive and more on preparing aircraft for operational missions. The difference could translate directly into higher readiness across the bomber fleet. Production of the new engines also reflects the industrial dimension of strategic power. Hundreds of F-130 engines will be manufactured to support the modernization program, linking aerospace companies, suppliers, and skilled workers across the United States. While military capability often dominates public discussion, sustaining that capability depends upon an equally resilient industrial base. Factories, engineering teams, and logistics networks become part of the national defense system long before a bomber ever leaves the runway. The modernization effort extends far beyond propulsion. Engineers understand that an aircraft expected to operate into the 2050s cannot rely on sensors designed decades earlier. Future conflicts will unfold inside increasingly complex electronic environments where information moves as rapidly as missiles themselves. Detecting threats, identifying targets, and coordinating with other military assets require capabilities unimaginable when the original B-52 entered service. That requirement led to one of the program's most significant technological leaps, a completely new active electronically scanned array radar. Derived from radar technologies proven aboard aircraft such as the F/A-18 Super Hornet and the F-15E Strike Eagle, the new system dramatically expands what the bomber can observe and process. High-resolution mapping, maritime surveillance, and improved target tracking provide crews with a level of situational awareness far beyond previous generations. The aircraft will no longer depend upon aging sensors built for another century of warfare. Imagine the difference from the crew's perspective. Instead of relying on older displays with limited processing capability, information arrives faster, clearer, and with far greater precision. Terrain can be mapped in remarkable detail, enemy ships identified at long distances, and complex operational environments interpreted more efficiently. Modern radar becomes more than a navigation tool. It functions as one of the aircraft's primary sources of battlefield intelligence. Yet perhaps the most dramatic evolution lies not in how the B-52J sees the battlefield, but in how it fights. During the early decades of its career, the bomber often needed to approach targets directly before releasing its weapons. That approach exposed crews to increasingly dangerous air defense systems as technology advanced. Modern strategic thinking turns that concept upside down. Rather than penetrating heavily defended airspace whenever possible, the B-52J is being optimized to strike from well beyond the reach of many enemy defenses. Its expanding arsenal reflects this new philosophy. The AGM-158 JASSM-ER provides long-range precision strike capability against high-value land targets, while allowing the launch aircraft to remain at considerable distance. The AGM-158C LRASM extends that reach into the maritime domain, giving the bomber the ability to threaten sophisticated naval forces operating across vast ocean regions. Future integration of additional long-range systems ensures that the aircraft remains compatible with weapons still being developed today. Perhaps the most closely watched addition is the Long-Range Standoff Weapon, or LRSO. Designed as the next generation of nuclear-capable cruise missiles, LRSO will preserve the bomber's role within America's strategic nuclear deterrent while taking advantage of modern guidance, survivability, and standoff capabilities. This combination allows the B-52J to continue serving as one leg of the United States nuclear triad, ensuring that even an aircraft first conceived during the Cold War remains relevant in a dramatically different strategic environment. Military planners are also looking beyond current inventories. Hypersonic weapons capable of traveling at speeds exceeding Mach 5 continue attracting significant attention throughout the defense community. While their development remains ongoing, the spacious design of the B-52 offers valuable flexibility for integrating future systems as they mature. Once again, the bomber's greatest strength is not merely the weapons it carries today, but its ability to accommodate the weapons of tomorrow. This transformation fundamentally changes the bomber's role. The B-52J is no longer expected to force its way through dense air defense networks in the manner envisioned during earlier eras. Instead, it becomes an airborne missile carrier capable of launching coordinated waves of precision weapons from positions far outside the most dangerous engagement zones. Enemy commanders may never even detect the aircraft before missiles begin arriving on their intended targets. Viewed from this perspective, the Stratofortress begins to resemble something entirely different from the image many people still associate with it. Rather than a traditional gravity bomber, it functions as a strategic weapons platform capable of supporting joint operations across enormous geographic areas. It complements stealth aircraft instead of competing with them, providing overwhelming firepower while other platforms perform missions requiring lower observability. Testing and integration will take years to complete, reflecting the complexity of the modernization effort. Prototype aircraft will undergo extensive ground evaluations before entering demanding flight test programs designed to validate every new system. Engineers, pilots, software specialists, and maintenance personnel will work together through countless hours of analysis to ensure that every modification performs as intended. Such caution may appear slow from the outside, but strategic aviation leaves little room for shortcuts. As each milestone is completed, the picture becomes increasingly clear. The B-52J is not intended to preserve history for sentimental reasons. It is being built because American defense planners believe the aircraft fills a role that no other platform can perform as efficiently. Age has become secondary to capability. What truly matters is the combination of payload, endurance, affordability, and adaptability that remains extraordinarily difficult to replicate. Yet one final question still hangs over the entire program. If the United States is simultaneously introducing the stealthy B-21 Raider while investing billions to modernize the B-52J, why operate two very different bombers at the same time? At first glance, the strategy appears redundant. But hidden behind that decision is a much larger vision, one that reveals how the United States expects future wars to be fought, and why the oldest bomber in its inventory may become one of the most important pieces of that strategy. For years, the conversation surrounding American strategic aviation revolved around a single assumption: stealth would eventually replace everything that came before it. As air defense systems became more sophisticated, the logic seemed impossible to challenge. Aircraft that could avoid detection would dominate future battlefields, while older bombers would gradually disappear from frontline service. It was a convincing narrative, repeated so often that many accepted it as an inevitable truth. Yet inside the Pentagon, another strategy was quietly taking shape, one that relied not on replacing the past, but on combining it with the future. Military planners understood that no single aircraft, regardless of how advanced it might be, could perform every mission equally well. The B-21 Raider represents the next generation of penetrating stealth bombers, designed to operate inside heavily defended airspace, where survival depends on remaining nearly invisible. Its role is to reach targets that few other aircraft can approach, gathering advantages through low observability and advanced networking. But stealth alone does not solve every operational challenge. Once a conflict expands across thousands of miles, sheer capacity and endurance become just as important as remaining unseen. That is where the B-52J enters the picture. Rather than competing with the B-21 Raider, it complements it. While stealth bombers slip through the most dangerous defensive networks, the B-52J can remain hundreds of miles away, launching large numbers of precision-guided weapons toward targets already identified by satellites, intelligence assets, naval forces, or stealth aircraft. The two bombers perform different tasks, but together they create a layered strategy that is significantly more flexible than relying on either platform alone. Imagine the opening hours of a major conflict in the Indo-Pacific or another contested region. Long before the world sees dramatic headlines, satellites begin tracking military movements, intelligence analysts monitor electronic emissions, and commanders assemble an operational picture stretching across thousands of miles. Somewhere beyond the immediate area of tension, B-21 Raiders move toward heavily defended objectives, exploiting their stealth characteristics to penetrate sophisticated air defense systems. Farther behind them, formations of B-52JS wait outside the reach of many enemy missile batteries, carrying enormous arsenals prepared for long-range engagement. They are not competing for the same mission. They are executing different chapters of the same operational plan. As the first wave of strikes unfolds, the true value of this partnership begins to emerge. Stealth aircraft can disrupt critical command centers, disable advanced radar installations, and create temporary openings within defensive networks. Once those opportunities appear, the B-52J can unleash successive waves of standoff weapons from positions that minimize risk to the aircraft and its crews. Cruise missiles, anti-ship missiles, and future long-range precision weapons multiply the pressure until defending forces face attacks arriving from multiple directions simultaneously. The objective is not simply to destroy targets. It is to overwhelm decision-making itself. This concept reflects a broader transformation in modern warfare. Victory is no longer determined solely by which aircraft flies fastest or carries the newest technology. Increasingly, success depends upon integrating diverse systems into a coordinated network capable of sharing information and applying force across enormous distances. Aircraft, satellites, naval vessels, submarines, unmanned systems, and cyber capabilities now function as interconnected elements rather than isolated platforms. Within that network, the B-52J becomes something far greater than an aging bomber. It becomes a high-capacity node capable of delivering decisive firepower whenever the larger system demands it. The strategic implications extend beyond combat operations. Military capability influences diplomacy long before the first weapon is launched. Potential adversaries constantly evaluate not only the strength of individual platforms, but also the resilience of the force behind them. By maintaining both the B-21 Raider and the modernized B-52J, the United States demonstrates that it is preparing for multiple forms of conflict rather than betting everything on a single technological solution. That diversity complicates an opponent's planning and increases the uncertainty surrounding any attempt to challenge American military power. This is the twist that many people overlook. The $12 billion investment is not fundamentally about preserving an old airplane. It is about preserving strategic options. Replacing the B-52 with another entirely new bomber would consume decades of development, enormous financial resources, and valuable industrial capacity. Modernizing an existing platform with proven structural integrity allows the Air Force to accelerate capability while reducing many of the risks associated with starting from scratch. The airframe becomes a foundation upon which successive generations of technology can continue to evolve. Viewed from this perspective, the B-52J represents one of the most practical examples of military innovation. Innovation does not always require abandoning what already works. Sometimes it means recognizing hidden potential within an established system and expanding it with modern engineering. The bomber's familiar silhouette disguises an aircraft increasingly defined by digital architecture, advanced sensors, efficient propulsion, and precision-guided weapons unimaginable to the engineers who first designed it. The appearance remains historic, but the capability continues moving forward. If current plans remain unchanged, the B-52 will serve beyond its 100th year. That possibility sounds almost unbelievable when measured against the history of military aviation. Entire generations of fighters, bombers, and reconnaissance aircraft have entered service, achieved fame, and disappeared while the Stratofortress continued adapting to new realities. Very few machines in history have demonstrated such resilience, and even fewer have done so while remaining central to national defense. There is something almost symbolic about that longevity. The rivets holding together portions of the aircraft were installed during an era when computers filled entire rooms, satellites had not yet reached orbit, and space exploration remained a dream. Today, those same wings carry weapons guided by satellites, supported by artificial intelligence-assisted planning systems, and connected through digital communication networks spanning the globe. The aircraft has become a bridge between generations of technology, proving that thoughtful engineering can outlast changing fashions in military design. Perhaps that is the greatest lesson of the B-52 story. History often celebrates revolutionary breakthroughs while overlooking the quiet power of continuous improvement. Headlines usually focus on brand-new aircraft making their first flights, but true strategic advantage sometimes belongs to platforms that evolve patiently across decades. The Stratofortress has survived not because it resisted change, but because it embraced it, accepting new missions, new technologies, and new roles whenever the world demanded them. One day, the B-52 will inevitably make its final flight. Every aircraft, regardless of its achievements, eventually reaches the end of its journey. Yet that day remains farther away than almost anyone imagined when the bomber first lifted off the runway in 1952. Instead of fading into history during the 20th century, it is preparing to help shape the strategic landscape of the 21st. Few military programs have rewritten expectations so completely. When future historians examine the evolution of American air power, they may discover that the most remarkable chapter was never about the introduction of a revolutionary bomber. It was about the decision to believe that an extraordinary design could continue evolving long after the world expected it to disappear. The B-21 Raider may represent the future of stealth, but the B-52J proves that experience, adaptability, and vision remain powerful weapons in their own right. In the end, the Stratofortress is no longer simply a survivor of the Cold War. It has become living evidence that military strength is not measured only by how new a machine is, but by how effectively it continues to answer the challenges of a changing world. More than 70 years after its first flight, the giant bomber still refuses to become history. Instead, it is preparing to write another chapter, one that could carry it beyond a full century in the skies and secure its place as one of the most extraordinary combat aircraft ever built.